Kia ora Year 12, here's question 4 from the May 2018 Stats 2 paper, paper 71. So this is a question in which we need to use our rules about combinations of normal random variables. And the question goes like this: the volume in millilitres of a small cup of coffee has this distribution. So this is normally distributed with the following mean and variance. Remember that number's giving me the variance, not the standard deviation. And the volume of a large cup of coffee is 1.5 times that. So we're going to start off by just defining a few things. So let the volume of the large cup be L. L is equal to 1.5 S. So using our rules about linear combinations of normal random variables, we've got the following properties. The expected value of L is equal to the expected value of that, which is 1.5 times E of S. So 1.5 times 103.4, and that equals 155.1, and that unit is in millilitres. Okay, so that's the first part done. Next, we have to find the standard deviation. So remember, we don't work with the standard deviation when we're looking at combinations of random variables. We always work with the variance. So the variance of L is equal to the variance of 1.5S, which is 1.5 squared times the variance of S. Let's change my pen colour. So that works out to be 1.5 squared, so 2.25 times 10.2, giving me 22.95. And we were asked for the standard deviation. So that's equal to the square root of this, which is 4.79, and that's to 3 significant figures. So in this case, this was an exact value anyway, but don't round whatever you've got here, just save it until the very end. Okay, so that's the first part of the question done. Let's go on to the second part, where we're going to use that distribution to find a probability. So here's part 2. Find the probability that the total volume of a randomly chosen small cup of coffee and a randomly chosen large cup of coffee is greater than 250 ml. So we want to define a new variable, which we'll say T is equal to the volume of the small cup and of the large cup. And now we need to figure out the mean of that distribution. So that works out to be 258.5 ml. And the variance of that distribution. So the variance of T will equal the variance of the two separate ones. So we're assuming in here that they're independent, and that's fine. Okay, well, it's fine for here. Now, what have we got here? So adding those two numbers together, we get 10.2 plus 22.95. And that gives me 33.15. So now we're good to go. We also know that the total will be normally distributed because the two variables that go into it are normally distributed. So we're ready to figure out now the probability that the total is greater than 250. We're standardizing as usual using the mean and the standard deviation. Okay, you've probably stopped watching by this point, but just in case, I'll keep going. So we get a Z value of negative 1.476. Let's quickly sketch that. So we're looking for this probability here. And so that's the same as the reversed one, which is the normal CDF from 1.476 back. Okay, so my final answer here is 0.930.